Okay, let's look at some of the main types of angles that we're going to see. So we're always going to draw what's called our ASTC graph from last year. And we're always going to mark 0 and 180 and 360 if we wanted to. So following the notes, where is an angle of 150 degrees? Well, that's all the way around and just shy of 180. Which I know is 150 degrees, which means that my tiny little reference angle is 180 minus 150 is equal to 30. Now notice I did that calculation. I didn't just do it in my head. I want to remember, if I want this angle right here, all I do is I take this and I subtract that. So let's see if we can apply that with radians. So let's draw a graph and let's mark 0, and this time not 180 but pi, and then do an angle of 3 pi over 4. So we know that we want to change pi to be a denominator that we're working with. So if we're working with over 4, we want to change pi to be over 4 by multiplying the bottom by 4. And we want to multiply the top by 4. Then we want to geometrically break up the ASTC graph into 4 parts. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, just like we did in the last section. So where does 3 pi over 4 lay? Well, it lays right here. I'm going to put an arrow tip. So here is 3 pi over 4. That is a radian measure. Now, how do I get my little angle? Well, remember when we did degrees, we just did this minus this is equal to our angle. So let's do that. 4 pi over 3 minus, 4 pi over 4 minus 3 pi over 4 equals pi over 4, which means that this reference angle is pi over 4. Now what is pi divided by 4? Well, pi divided by 4, 180 divided by 4 is 45, and that looks perfect. So we need to be very comfortable using both degrees and radians. Let's do another one. So now we're going to be getting more comfortable with degrees. So let's start by radians. Let's start by marking 0 and pi. Now this question is asking for 6 pi over 5. So where is 6 pi over 5? So 6 pi over 5, well, I'm over 5, so I got to get pi to be over 5. And then I have to have a numerator of 5 as well, and I want to break it up into sections of 5. So if I want to go to 6, 1, 2, 3, 4, 5, 6. So I know that my terminal arm is down here. And I know that my angle all the way around to my terminal arm is 6 pi over 5. And therefore my reference, if I do a subtraction, remember, if we're past, we have to do this minus this. Obviously, we have to get a positive answer. So 6 pi over 5 minus 5 pi over 5 equals pi over 5. And that is the reference angle. That goes inside the triangle near the origin, always touching the x-axis. Now, what if they gave us a decimal? Well, we're not very comfortable with radians already, but let's just try. So let's say they give us 5.64. Well, we're going to mark 0 and we're going to mark pi, but this time we're doing decimals, so we're going to change pi to be a decimal 3.14. Excuse me. So now we would have 0 and pi, and then we also have 2 pi, and we know that 2 pi is 6.28. So where would 5.64 fall? Well, all the way around is 6.24, and halfway around is 3.14. So 5.64 is pretty close to 6.28, so we're going to have our terminal arm in the fourth quadrant. I'm going to put an arrow from my principal axis all the way around to the terminal arm, and I'm going to call that angle 5.64. And then if I want to get theta, I must do a subtraction. And I must take this, and I must subtract that, just like we did in degrees last year. So 6.28 minus 5.64 is equal to 0.64, and that is our reference angle. So you can see in the notes that we have angles in standard position. We're back up on the top left. Angles in standard position, the 150, and we find, so the angles in standard position are always from the principal axis to the terminal arm. I'm going to draw in all 4 arrows. From the principal axis to the terminal arm. From the principal axis to the terminal arm. From the principal axis to the terminal arm. That is always the angle in standard position. And the reference angle in big blue is the tiny little angle inside the triangle hugging the x-axis, not the y-axis, touching the x-axis near the origin. So please feel free to take a look at the notes for a more detailed and thorough run-through of all these points, the exact English instructions of what a reference angle is and what a standard position angle is, and all of the more complicated finding what the reference angles are, adding and subtracting fractions with the lowest common denominator. But again, this should be a lot of review from grade 11, whereby we're putting angles on a coordinate axis and finding out what different aspects of the graph are. We're going to be using all of these different concepts very fast in the future, so we want to have the foundations done very well. Please do all the homework before you jump sections. Okay, we just looked at reference angles and angles in standard position. Now we're going to take a look at positive and negative angles and coterminal angles and general solutions. So if I have a graph and I have an angle starting from the positive x-axis called the principal axis, and I go to my terminal arm, that is the angle in standard position, and that angle is positive. So what if we take a similar graph, and again we always start from the positive x-axis, but what if we go in, the other direction and put in a terminal arm? Well, that is a negative angle, where before it was a positive angle. So positive is from the principal axis, the positive x-axis, counterclockwise around the circle. And a negative angle is again starting from the principal axis and clockwise around the circle. Now let's take a look at a definition of a coterminal angle, and this time let's do it in radians. So let's draw a graph, and let's put an angle of 3 pi over 4. I'm going to do that on the inside, 3 pi over 4. Remember, if you want to mark 0 and pi and change pi to be a denominator that you're working with, that's easier to count. So what's a coterminal? Well, a coterminal angle, I'm going to do in red. We go to the angle, we pass it, we go around, and we go to it again, which means that I'm just my angle in standard position, 3 pi over 4, and I'm adding 360, but now that means 2 pi. Now I can add fractions with a denominator that I'm working with over 8. That means I multiplied the bottom by 4, which means I have to multiply the top, a lowest common denominator of 4, which means I have to multiply the bottom by 4, which means I have to divide the top by 4, which is 11 pi. And I can call it, which is 8 pi, and then I can add those and get 11 pi over 4 is my coterminal angle. What if they ask for a negative coterminal angle? I'm going to do that in big blue. So we're going to start from the principal axis, and we're going in the negative direction around. Well, there's a negative coterminal angle. And how would I get that? Well, I would simply take my angle in standard position that I did before, and I would subtract 2 pi. And that's over 1, and I can get a lowest common denominator. of 4. And if I multiply the bottom by 4, I have to multiply the top by 4. And 3 pi over 4 minus 8 pi over 4, well, 3 pi minus 8 pi is negative 5 pi over 4. Our big blue angle, the negative angle. Now, lots of the times they ask for what's called the general solution. Theta general is equal to theta STP given or found plus Pn, the period n. Now, in this case, the period is equal to 2 pi because that's the difference in the terminal arms from getting to it and getting to it again. So we say plus 2 pi n, comma NEI or NEZ or some version of that, depending on what your teacher likes. Therefore, if that is my general equation, keep in mind, underlining in big blue, this 2 pi was the period, and that's going to change a lot. On our formula sheets, I've actually said theta plus Pn, which is more specific. And then therefore, theta gen is equal to my angle in standard position, 3 pi over 4, the first black arrow that we were working with, plus 2 pi n comma NEI, which accounts for every answer in the future. If n is 1, we're adding 2 pi once. If n is negative 1, another integer, we're subtracting 2 pi. If n is negative 1, 2 pi times negative 1 is negative 2 pi, and we're subtracting 2 pi. So when we added 2 pi, off to the right, we got our first answer. When we subtracted 2 pi, we got our other answer. And this general solution covers all of the answers. So sometimes they say sometimes they say between 0 and theta between 0 and 2 pi. And sometimes we answer based on that, and sometimes they ask for the general solution, and sometimes we answer based on that.